In today's session, I will be discussing a topic related to trigonometry, that is, radian measure of an angle. So, the basic outline of today's session is the basic definitions which I will be explaining are trigonometry, which will be followed by the definition of angle and directed angle. Finally, what is the radian measure of an angle? Once we are familiar with all these three basic definitions, we can move on to theorems. So in the second session, I will be discussing about three main theorems used in application with radian measure of an angle. So the first theorem is a radian is a constant. And the second theorem states that if an arc of length s subtends an angle theta at the center of a circle of radius r, then the length of the arc s would be equal to the product of radius of the circle times the angle subtended at the center of the circle by the arc, that is theta. So that is s is equal to r theta. And the third theorem would be the area of a sector of a circle of radius r is half times r square theta, where theta in radians is the angle of the sector. The third theorem gives us the formula for area of a sector of a circle, which is half r square theta. So the first definition would be trigonometry. So trigonometry is a branch of mathematics that deals with the measurement of triangles. So first let us take an example. So when we consider a triangle, we have, when we consider this triangle ABC, it has three angles, that is angle A, which is equal to 60 degrees, angle B, which is equal to 60 degrees, and angle C, which is equal to 60 degrees. And it also has three sides, that is side AB, which is 12 centimeters, side BC, which is 12 centimeters, and side AC, which is 12 centimeters. So these are all the only measurements that can be taken in any type of a given triangle. So in our case, we have taken an equilateral triangle. So therefore, a triangle, a measurement of triangle consists of 6 elements, which can be further divided into two sets, that is three angles in our case are angle A, which is equal to 60 degrees, angle B, which is equal to 60 degrees, and angle C, which is equal to 60 degrees. And three sides are side AB, which is this one, 12 centimeters, side AC, side AB, which is 12 centimeters, side AC, which is also 12 centimeters, and side BC, which is also 12 centimeters. So therefore, the measurement of triangle includes all the 6 elements of triangle, that is 3 of its angles and 3 of its side. So same thing is here. Trigonometry is a branch of mathematics that deals with the measurement of triangles, and measurement of triangle involves measurement of all 6 elements of triangle, that is its 3 angles and 3 sides. So let us take an example, our next example of acute angle triangle. So when we consider this acute angle triangle ABC consists of angle A 55 degrees, angle B, that is 75 degrees, and angle C, that is 55 degrees, and its sides are measure side AB 4 centimeters, side BC 4 centimeters, and side AC, that is 4.5 centimeters. So when we take when we draw a median from one of its vertex, that is B, perpendicular to its base, that is AC, we can divide this acute angle triangle into two right angle triangles, that is triangle ABC is divided into triangle ADB and triangle BDC. So now these two right angle triangles measure each angle A So first let us consider the triangle ADB. Angle A is 55 degrees, angle D which is 90 degrees, and angle B which is 35 degrees, and its sides measure side AB 4 centimeters, side AD which is 2.25 centimeters, and the height of the triangle ABC, that is 3.3 centimeters. Coming to the next right angle triangle, that is BDC. Its angles are side C 55 degrees, angle C 55 degrees, angle D 90 degrees, and angle B 35 degrees. And its sides measure side BC 4 centimeters, side DC 2.25 centimeters, and side BD, that is 3.3 centimeters. So this acute angle triangle can be easily converted into a right angle triangle by drawing a median from one of its vertex perpendicular to its base AC. Next, let us take an example of obtuse angle triangle. So here we have an obtuse angle triangle where its angle is more than 90 degrees, that is here in our case angle A, which is 120 degrees. So this triangle has 6 angles, that is angle A 120 degrees, angle B 30 degrees, and angle C 30 degrees. And its sides measure side AC 4 centimeters, side BC 4 centimeters, and side AB 4 centimeters, and side BC, that is 6.9 centimeters. This triangle can be easily converted into a right angle triangle by drawing a median from one of its vertex perpendicular to its base, that is BC. So when we do this obtuse angle triangle is easily converted into two right angle triangle. That is, triangle ABC is converted into triangle ADC and ADB. So the first triangle ADC also consists of three angles, that is angle D 90 degrees, angle A which is 60 degrees, angle C which is 30 degrees, and its sides measure AC 4 centimeter, C and D, that is 3.45 centimeter, and its side AD would 2 centimeters. And this triangle ADB consists of three angles, that is angle A 60 degrees, angle D that is 3.4, angle D that is 90 degrees, angle B 30 degrees, and its sides are side AB, that is 4 centimeters, side AD, that would be 2 centimeters, and side BD, that is 3.45 centimeters. So this obtuse angle also can be converted into two right angle triangles by drawing a median from by drawing an altitude from one of its vertex perpendicular to its base BC. So from this, we can say that when we, instead of measuring different types of triangle like obtuse angle triangle, like acute angle triangle, obtuse angle triangle, or equilateral triangle, isosceles triangle, this would be considered as isosceles triangle because it has two equal angles and two equal sides. So isosceles triangle, we can measure only one type of triangle, that is right angle triangle. So in order to make it easier for us, therefore the calculations in trigonometry are restricted only to right angle triangles in order to make it easier for us. So the same thing is written here. Calculations in trigonometry are restricted to right angle triangle because other types of triangles such as acute angle triangle, obtuse angle triangle, etc. can be converted into right angled triangle by drawing an altitude from one of its vertex.